This is the continuation of the previous video. In the last video, I showed you how to use the Tag tag from Texas Instruments, and in this video I would like to show you how to use this M24LR chip. Since I don't have the M24LR tag, I'm using the dynamic NFC board, which is part of the discovery kit you can buy from internet for less than 20 pounds. And before I do that, there are a couple of things that I would like to show you, and that is also, this is also a bug fix. Now when I showed you how to use this iCode SLI tag, and when you click this EAS, the electronic article surveillance, the bits what I showed you was wrong. If you look at this documentation here, and you can get this EAS bits using the command the EAS alarm. And here what the documentation says, the very first bit is the LSB. If you have seen my previous version of the software, this value was reversed. It was 00101111. So that is one of the fix which is done in version 1.5.2. And the other small changes which is done here is to bulk write. We have seen this in the previous video, how to write the string. And what we have done here is, we just added one more feature. And this iCode, this tag, you have to be very careful. Now it depends on how you place this on the tag. So I'm going to read the entire tag. So I didn't click this bulk. Now here we have added a feature called copy hex value to the grid. Now assume that I want to fill this entire tag with a default value, or if I want to fill a part of the tag with some default value, you can use this section here. Now I'm going to show you what we have done. So assume that I want to fill this with the AA, BB, CC and DD, and I want to copy this. It is done in two steps. First you copy the data into the grid, and just like copying within the software and not to the tag. I would like to copy this from block number 11 to say block number 27. Save. So you can see this is just a transfer of 4 bytes from the left side to the right hand side. And next is I'm going to physically write from block number 11 whatever is in here up to block number 27. I'm going to write. Now there's a bit of a warning here. Now you can see that, okay, so it says the bulk write successful. If you look at the command I have used, so this is the update binary and writing more than 4 bytes. Now this is also like it's also called as a bulk writing, and the write is successful. So apart from that, we are ready for our next tag. So this one, this tag is not meant to be used with OmniKey 5421 reader writer, because if you see the OmniKey documentation, they have not mentioned this M24LR tag. However, so I'm going to show you what you can do with this tag. Now this tag is something different from the tag we have seen before. That's the iCode and the Tag. This board, I would say, has got 4 kilobits of memory, and the memory is organized into 4 sectors, sector 0, 1, 2 and 3, and each sector has got 1 kilobits of memory space. So if you scroll down this document, you can see that the block numbers start from block 0 and goes up to block 31 in sector 0, and from 32 onwards, the next 32 blocks belongs to sector 1, and the next 32 block belongs to sector 2, and next, and altogether you got 127 blocks. I can read this, but the only problem I saw with this board is, so you can't just place it right here. Now you will lose the connection in now and then. So whenever you see this reader flashing the light, so that means you lost the connection. I just don't know why it works like that. Now what I have done is I'm going to place this tiny box here, and I'm going to place it. You have to make sure the antenna is over here. This is the antenna. Make sure the antenna is right above the reader. Okay, I'm going to activate, and we're going to get AFI. We have seen how to modify AFI and the DSFID. All these commands work, and the EAS is not present in this board, so you will get error message. And the memory, you can see it has got 128 blocks. I'm going to read the entire memory into the program. So you can see while you are reading this tag, the screen literally it's hanging here, because this is something we will improve in the future releases. So this is we have not done any threading here. It's just waiting for the read to complete. And you can see here, with the same commands, existing commands, we are able to read even this board as well. But there is a limitation here. So limitation is with the reader writer. Now I can write any of these individual block. I can go to block, I'm just going to clear here. I'm going to go to block 120. So write AA, BB, CC, DD. I can write, and this, the write is not successful here because the reader has lost the connection. So this is something I've noticed. So you have to somehow bear with this. So you have to activate again. Okay, I'm going to write. Say write, and now you got write is successful. So likewise you can read as well. Now I'm going to read this, clear, read it again. This is the read binary command, and the lock doesn't work here, because if you just try to lock, I'm going to lock block number, go to this block number 0. I'm going to lock it and say update. Now the lock failed. I don't know whether it's because of the connection. If you look at that, if you try to click, when I clicked on get, I got error, because there's something to do with the way, probably next problem, the way you keep the board. Now you have to activate again, get, and I'm going to lock this block 1, update. The lock is successful. It says the lock is done. However, okay, that the actual lock failed actually. The reason is this, in this tag, the lock is not linked to the block. The lock is linked to the entire sector, and there is no command in OmniKey to lock the entire sector. So we have to use what is called a custom command. Now probably after this video, all my next future videos will be on how to do the custom command. So when I do that, I will not be using OmniK. I'll be using the CR95HF chipset board. So you can try to you can just, I wanted to show you I wanted to show you how to read and write at least these type of blocks. And I don't want to try the lock here. I'm sure you can lock. I don't know if you can lock or not, but I don't want to try on this board, because I have got only one board, and if I lock here, I don't know if there's any way to unlock it. In theory, we know you cannot unlock, but because this is a kind of a dynamic board, or the board, I'm thinking there must be somewhere, some jumper setting which can clear the lock. I don't think it is so, but so I'm trying to get some LR series tags from internet and explore the lock. So if you try to lock, we get the error message 6400. If you look into the documentation of OmniKey, 6400 refers to execution error. But I'm 100% sure the lock wouldn't work, because the way the lock is done in this board is different. Now, I also had a difficulty doing the bulk write. I don't know whether it's something to do with the board or the timings, and I'm going to show you. So I'm going to use this the new feature to do some bulk writing. I'm going to write this from block number, say 100 to 200 and 110. Save. Okay, here, and I'm going to physically write from block number 100 to 110. So clear. Now I just after sending this, I just got error message. I'm not very sure why it is. So let's not really worry about this tag here, because this board works well with. So I'll be using this board here, the green board, and which is based on the CR95HF chipset. So this board works very well with this. Probably in the next video we're going to say how to send the custom commands and how to send all the commands byte by byte. And finally we'll see what output we get when I try to read the security bit. Oh, sorry, lost the connection again. Now get do the bulk read, the memory size, do the bulk read. You can see the light flashing here. So there's a lot of things are happening here. Firstly, I'm reading the 127 blocks. Then for each block, I'm sending the commands to read the security status. And you can see that all the security status they worked here. They're returning they're not locked. However, we just saw now there's no way to lock it. So at any point of time you can still read the entire security status. And you can see that the security status command has returned 00, and so I think that's all in this video. So in the next video will be interesting. We're going to see about how the activation, the anti-collision, and we're going to see how to use the low-level commands. So that's all, and see you in the next video.